All right, today we're going to be doing two-step equations of linear equations. So before we're going to do that, I'm going to kind of go through the warm-up really quickly, just so we know what the inverse operation means. So when we're trying to solve for a variable or solve for something, we got to undo whatever's happening to it. So what I mean by that is, like on A right here, we want to solve for M. And M is on the side with 12, and 12 is adding to M. So if I want to undo that 12, I have to do the opposite operation. So because it says M plus 12, in order to undo that 12, I have to do the opposite, which is subtraction. So I have to subtract 12 from M, but what I do to one side, I must do to the other to keep the equation balanced. So then I'm left with M on the left side equals, and 10 minus 12 will get us a negative 2. All right. So I'm just going to do a few that look kind of tricky. So this one you'll see a lot on C. So it says negative 7y equals 91. All right. And the thing I'm drawing right now is your railroad tracks, because that's just what y'all have been taught in the past. So I want to make sure we're staying consistent. So negative 7y equals negative 91. So when there isn't a adding, subtracting, multiplication, or division sign here, we need to assume that when a letter and a number are tied together like this, with no space in between, no operation in between, we know that they are multiplication. There's multiplication there. So in order to undo that multiplication, we must divide by the coefficient. And remember, the coefficient is that negative 7. So we're going to divide by negative 7. What you do to one side, you must do to the other. So y is 13, because a negative divided by a negative gets us a positive. All right. This one over here is a little tricky. Okay, so we see that this equation right here says a divided by 9 equals negative 4. So whenever the variable is inside of the fraction, so like here, it's inside the fraction, it's being divided by. Okay, so there's a number that is dividing by our variable. So in order to undo division, we must multiply. So as long as the variable is on top, we just multiply by that bottom number to get rid of it. Well, what you do on one side, you have to do on the other. So we're left with A equals a negative 36. And the reason why I say if A, or your variable, is inside the fraction, because we get to this one over here, and notice how x is outside the fraction. So when x is outside the fraction, it is being multiplied by this fraction. All right, there's multiplication going on here. It's just being multiplied by a fraction. So in order to get rid of this multiplication, we must divide by 2 over 3. And when you do that, x should equal x should equal 15. Another way you can do this, and I'm going to erase this. Another way you can do this, okay? If there's multiplication going on here, you can still get rid of the bottom number by multiplying by 3. So then I'm left with 2x equals 30. And then I divide by 2, which still gets me x equals 15. So do whatever one makes sense to you, okay? I like the dividing thing because it keeps it consistent. Like if the multiplications happen to the x, I divide whatever's in front of it off. Okay, and that's something you can plug into your calculator. All right, so let's move on to two-step equations then. Okay, so there are 2 steps here. In order to solve your 2-step linear equations, you must undo the addition or subtraction or just remove your constant first. Same thing. Then you must undo the multiplication or division that's happening to x or remove your coefficient. All right, so for example, okay, so step 1 was to undo the addition or subtraction. So we love the railroad tracks. So if we're looking at this 7x minus 4 equals 3, we want to move everything to the opposite side of the variable. So the variable is on the left side, so I want to move everything else to the right. So the constant that I'm moving is this -4, okay? So if this says 7x minus 4, in order to undo that -4 or subtracting a 4, I must add 4. What I do on one side, I must do to the other. Okay, I'm left with 7x equals 7. And then I need to divide by 7 because that's step 2. Step 2 is to undo the multiplication or division or remove the coefficient. If we're looking right here, 7 is the coefficient in front of the x, so I gotta remove it. I remove it by dividing by that coefficient. So x equals 1. All right. I'm going to do number 2 and number 3 are very similar to that one. So I'm going to move on to this one, but you will get the answers when I post the picture of the notes. So this one right here. Okay, we're going to draw our railroad tracks. First step, undo the addition or subtraction of the constant term. And remember, we want to move the constant that's on the same side as the variable. Well, the same side of the variable is this 2. So I need to remove the 2 by undoing the addition. I undo the addition by subtracting. So I'm left with n divided by 7 equals, well, 6 minus 2 is 4. Step 2 is to undo the multiplication or division or the coefficient. Okay, so like I said in the warm-up part of this notes, we want to see if the variable is inside the fraction or is it outside the fraction when a fraction is present. So this n over 7 is a fraction. And if we're looking at the fraction, n is inside. So because n is inside, this means that there's division going on. So in order to undo that division, I must multiply by that bottom number. Well, what I do on one side, I must do to the other. These cancel out. N equals 4 times 7, which is 28. All right. All right, here's one that's a little different. Okay, so I'm going to do this one, and it's the same step every time this happens. So when you complete number 6, you're going to do the same process. Okay, so this one's just a little bit different because we have this ginormous fraction, right? We have x plus 11, and it's all divided by 8 equals -3. So when we have this big fraction like this, we have to get rid of the bottom first before we can do anything with this x plus 11. So in order to undo the bottom of a fraction, we are going to have to multiply by that denominator. Okay, and the denominator is the bottom of the fraction. Okay, so when we do that, it takes away that bottom part of that fraction and then leaves me with x plus 11, which is one step closer to solving for x. Well, what I do on one side, I must do to the other. So negative 3 times 8 gets me a negative 24. Watch your signs. Remember to watch your signs. Well, now I'm left with a single row of operations, which is exactly what I want. So now as I'm looking at this, I need to undo whatever's being done to x. So right now this says x plus 11. So I have to undo the addition of 11 by subtracting 11. When I subtract 11 from both sides, I get x equals negative 35. All right. There are two parts to this notes. The second part of this notes is over word problems. So that one might be a little bit longer, but I wanted to give you an idea of what solving two steps equation is like without the additional word problem chaos. Okay. All right. So I want you to practice 2, 3, and 6 and look at the notes for the process and the work and then the answer to see if you're correct. Bye, guys.